Today, we're going to pull back the curtain on the real hero of construction, rebar. It's that steel reinforcement that gives concrete its incredible strength. But here's the thing, a single mistake, just one tiny error in how it's inspected or installed can jeopardize an entire structure. So how do we make sure it's done right every single time? Let's get into it.
So, let me ask you something. When you look at a huge concrete building, what do you think is actually holding it all up? I mean, it's easy to say the concrete, right? But that's not the whole picture. Not even close. The real power is hidden from view.
And what is it? It's an unseen skeleton of steel. Honestly, that is the best way to think about rebar. It's the load-bearing framework inside the body of a building. And just like with our own bodies, if the bones are weak or if they're not in the right place, the whole thing is at risk of collapse. Which brings us right to the start of the process. Quality control doesn't begin when you're placing the steel, it begins the moment that truck rolls onto your job site. This is your first line of defense, and if you mess this part up, you're setting yourself up for problems way down the line.
A good receiving inspection is actually a pretty straightforward three-step dance. First, you check the paperwork. You're hunting for the Mill Test Certificate, the MTC, to make sure the steel you've received is exactly what the project requires. Step 2, you check the markings on the bars themselves. For example, grade 60 steel has a continuous line rolled into it. It's a quick visual confirmation. And third, you get your hands on it and check the actual physical condition of the bar.
Now here's something that might surprise you. Not all rust is a bad thing. A little bit of light surface rust, what we call mill scale, can actually be a good thing. It creates a rough texture that helps the rebar really grab onto the concrete. But, and this is a big but, if you see heavy rust that's flaking off, causing little pits or actually making the bar thinner, that's an instant fail. That bar gets rejected on the spot because that kind of corrosion kills the steel's strength before it's even in the ground. Okay, so you've accepted a shipment of good rebar. Now you have to store it correctly to keep it that way. The rules are simple but crucial. You have to keep it elevated. We're talking at least 150 millimeters off the dirt to keep moisture and junk away. You've got to cover it with tarps to protect it from the weather. You need to keep your different sizes and grades separate so nobody grabs the wrong bar. And you use a first-in, first-out system so the oldest rebar gets used first. It's all about minimizing its exposure to the elements. All right, let's get into the technical stuff. The American Concrete Institute, or ACI, has a code book that is, well, massive. But for what we're talking about today, we can boil the most critical rules of placement down to just 3 golden numbers. If you nail these 3, you're building on a solid foundation, literally. Golden number 1 is 75 millimeters. So for any concrete that's poured right up against the earth, like a building's foundation, you need at least 75 millimeters of concrete between the rebar and the dirt. Why? It's simple, really. That thick layer of concrete is a shield. It's what protects the steel from all the moisture and other corrosive stuff on the ground. Our second golden number is 25 millimeters. This is the absolute minimum amount of clear space you need between parallel bars. Now, you might be thinking, why does such a tiny gap matter so much? Well, it's everything. That's the channel that lets the wet concrete flow all the way around every single bar, creating a perfect grip. If you don't have that gap, you get voids and air pockets, which means a weak spot in your structure.
And our third golden number isn't a measurement, it's a multiplier, 1.3. Look, you can't always have one long continuous piece of rebar. You have to connect or splice them together by overlapping them. But there's a catch. If you have a ton of splices all bunched up in one area, we're talking more than half your bars, that spot becomes a potential point of failure. So to make up for it, the ACI demands a Class B splice. That means you have to increase the length of that overlap by a factor of 1.3 to make extra sure the load gets transferred safely from one bar to the next.
Okay, all of this, the delivery, the storage, the placement, it all leads to this one single moment. It's right before the concrete trucks start rolling in. This is your last chance to get everything perfect. It is the final inspection, the absolute go or no-go decision. And in the industry, this moment has a formal name. It's called a hold point. It's exactly what it sounds like. It is a mandatory stop sign in the construction process. All work comes to a halt. Those concrete trucks do not move an inch until an authorized inspector gives the final sign-off, confirming every piece of that steel skeleton is perfect. So what's on that inspector's final checklist? Well, they are verifying everything we just talked about. Has the spacing and the concrete cover been checked and double-checked? Are the lap splices calculated correctly? Is the steel totally clean? No mud, no oil, no loose flaky rust. Are the supports and tie wires holding everything securely so nothing shifts during the pour? And, this is so important, have they taken photos of everything for the official records?
And that brings us to what's basically a mantra in this business. You've heard it before. If it wasn't documented, it never happened. Every single measurement, every verification, every tiny deviation, it all has to be recorded and signed off on. This isn't just about red tape. This is what ensures quality, it protects everyone involved from liability, and it creates a permanent record for the life of that building.
So we end on this one crucial question, because once that concrete starts to pour, it is final. There are no do-overs. That unseen skeleton of steel gets locked into place forever. The safety, the strength, the very integrity of that entire building, it all comes down to the care and the diligence that was taken before that pour ever began. So the question isn't just for the inspector, it's for everyone on the project. Is your steel ready?